All right, good night again. My name is Joshua Lin, and I am your teacher this evening. We didn't have a class last week, but I decided to just have a class today on the 1st of December just because I didn't have the time to do it tomorrow and to also make up for last week. Week before, I posted a video in place of having a physical class on what we'll be going through today. Did everyone here watch the video? Oh, okay. All right, but I'll still go and recap the material. So let me just start the slideshow. All right, so we'll be doing the problem solving process and we'll be actually trying to apply it to real world programming. So just to go over a question that we have done before, devise an algorithm that chooses the largest number among three integers that are inputted by the user. So the first stage is trying to find out the problem, what you are trying to solve. So in this case, that would be trying to find the largest of the three numbers that are inputted. So when you have the problem that you're trying to solve, the next thing you should do is try to see what your inputs, your outputs, and the processing that will take you from the inputs to those outputs would be required based on the problem. So going back to the original question, from this point on, it says devise an algorithm that chooses the largest number among three integers that are inputted by the user. So here you can see that three integers are the inputs, while this would be your output. So as you can see here, the output will be the largest of the three numbers and the inputs will be the three numbers themselves. So now we have to look at the processing, which is the steps that will be taken to manipulate these inputs right here in order to achieve this output right here. So if you are being asked to find the largest of three numbers, then you're gonna probably have to compare each number to then see which is the largest and then return that one. So that would be your processing in this situation, comparing each number to the rest to see which is the largest. So next, you'll draw up an IPO table to detail what your inputs and your processing and your output would be. So here on this table, I have number one, number two, and number three, your three integers that will be inputted. And then under processing, I have here compare whether number one is larger than number two and three. And then next, compare whether number two is larger than number one or three. So you're comparing each number to the rest. And then when you get down to number three, after having already done number one and two, there's no need. So if one and two aren't larger, then you can just return three. And then, of course, the output would be the largest number out of these three here. Right, so after this point, you would have to generate your possible solutions and likely just brainstorm how you could potentially get to the answer. So you could either write down your ideas or you could start up a draft solution, a draft program, and then just try to work your way through by just acting out the logic as you do it. As much as it is not advised to do so, a lot of people just still end up doing it. But here we'll just be looking at potential solutions. So what could we possibly do to get to the solution? Well, we could try using an array to store each value and then use a for loop to run through each value before comparing. Or we could just use the tree variable since, well, it's just tree numbers. So here you also look and see which is the most practical and what's the most efficient method. So it wouldn't really make sense using an array if you're going to be just doing less than 5 numbers. All right, so another possible solution is that we can then use an if then else conditional statement to compare each value with each other and then store the result based on that comparison. All right, so we can look at this and see if it can potentially fit into a solution. And if so, then we can approve that as a part of a solution. And then here at the end, you can just print it out to the user. So you could also here break down the program into its separate parts and then try to work out each part and then bring them back all together. So you can work out a separate solution for each possible function that you would have to undergo in the program, each functionality or each component or bit of processing that you would have to do. Like, let's say, for example, for this program, there's comparing and there's also storing variables and there's also printing out. So you can take each part separately and then bring them all together at the end. So after we found the best solution, we should then develop an algorithm for this problem or for the solution to this problem. So since we already did this, there is already an algorithm here. So here you can see the processing steps and the ideas here in action. So here you have your free integers here being read into the computer. Then you have your processing here where the first number is being compared against the second and third, and then well, in this case, it's the third number being compared against the second and the first, and then if not, then choose the second number. So the principle here is still the same. You are taking the numbers and then comparing them to each other and then putting them into an algorithm. And then here you have the largest number being printed out. So this would be just the graphical representation of all the processing steps and so on that you have already identified further up. That would represent a logical way to solve the problem that has been set for you. So next, we're going to have to use a trace table to test this solution to make sure that the solution that we develop is actually logical and actually produces the result that we really want it to result in. So going back here as we start off, when we're defining A, B, C, and LG as integers, they come here. I'll just get a laser pointer. They're here, and they're all set to 0. As these variables have now been declared, they have no values in them, so then they'll pick up values as we go on the program. But for now, they'll be all set to 0. So here, as they're now declared, This output is then printed out to the screen right after the declaration. So here, enter three integers. So let's say for the sake of demonstration, we have 4 as A, 5 as B, and 3 as C. So here the values are entered and now they've been stored in variables A, B, and C. So now at this point, we've gone into our if then else block where we're going to be comparing our numbers. So here we would have A being compared to B and C to see if it is larger than both. And as we can see here, while A is larger than C, it isn't larger than B. So nothing will be stored in LG since it is clearly not the largest number. So then we go into our next condition where B is then compared to A and C. So here you see B as 5 and then A as 4, C as 3. So since B being 5 is greater than both 4 and 3, then 5 gets stored into LG. So then at this point, this condition block gets terminated and LG is then outputted to the display. So it will then print largest number is equals to 5. Right, so as I did in the video that I uploaded, I'll also implement it in C and then run it with the test data to see if we are right. So just hold on for a second. All right, so can you see this program up here? Okay, good. So just to briefly walk you through this, so this would be where the variables are declared. So int A, B, C, and LG. So now at this point would be the print statement. So enter three numbers as you saw on here. So that would be your first input that would come up after all the variables have been declared. So then down here, you would enter A, B, and C. So that would be at this point, which you would also see right here. So then you would come into this if then else block. This is what it looks like in C. So here you have A being compared to B and C to see if A is larger than numbers B and C. So if so, then it would store the value of A inside of LG. See, this looks almost the same in C. So next, for the else if part, we would have B then being compared to A and C. This part is just the logical operator and just the same as this. So it'll just take both conditions into consideration, and if both are true, then it'll return. So if the condition then returns true, then B gets stored into LG. And else all of that, C then gets stored instead. And then down here, it would just print out the largest number. So this looks almost identical to the code that we have here. So if we enter in all of these values, then in theory, we should get back 5. So I'll just walk you through the processing as we go along. So compile and run this. So here you can see enter 3 numbers. So after all the variables have already been declared on the start of the program, then it will run enter 3 integers or enter 3 numbers as the first output. So then following the example code, let's put in 4, 5, and 3. So now once I press the enter key, the values would be entered into the variables, and then almost instantaneously the comparison if then else block would then run and then compare this to see if it's greater than the rest of these numbers, and then would compare this to see if it is bigger than 4 and 3. So according to this trace table, when I press enter, largest number equals 5 should show up, right? So when I press this, it then comes up. So that means that our program is working as we intended. So let me just exit out this. So as you can see here, I walked through all of the parts just now, from looking at the problem to then looking at the inputs, processing, and output in an overview and in more detail of the IPO table. We then looked at some possible solutions, and then we looked at an algorithm, even though we already did it. And then we tested that algorithm using a trace table, and then I just implemented it for you in C. All right, so does everyone understand? All right, so I'll just do one more demonstration and then we can start doing questions. Right, so let me just get back up the slideshow and we can continue. So example 2 from last week was this question here. So devise an algorithm that takes a number as input and then prints it if it's a prime number. So here you can see the problem would be determine whether the inputted number is a prime number or not, and then return to the screen, since that is what is being asked of us right here. So to just analyze it, the input would be one number, as you can see right here. It'll take in a number as an input. And then for output, it would then show whether that number is prime or not by printing it out. So then just to recap over how prime numbers are prime numbers, they are numbers that are only divisible by one and itself. So in theory, once you get to the halfway point between one and that number, when you get to half of that number, there should be in theory no more possible factors. And if when you start from 2 and get to that halfway point, if there is any other number that actually can divide it without remainder, then it is not a prime number. So in our processing, we would then have to divide the number by a series of potential factors to see whether it is actually divisible or not. So here you can see number is our input. So then to look at our processing, we would first have to determine how many potential factors we would have to divide it by. So as I said, we can use the halfway point. So it would then be number divided by 2. So we then divide the number by those potential factors. So pretty much all numbers from 2 to the halfway point. And we'll use the mod function for it to see whether there's a remainder or not. And then we would have to check to see whether there is a remainder or not. And then that would produce the desired output of whether there is a prime number or not. So to look at the algorithm that we've done here already, so we have here defined our variables that we would possibly need: an iterating variable, a variable that would take in the number, a variable that would be used to show whether it is a prime number or not by assigning a value, and a limit for us to reach. So here, looking back here, we can see we have input number. So we'll have a number here to input. And then for our limit, should have put it in, well, it is in here. So we would have here determining how many potential factors to divide it by. So we would then use that to find our limit. So that would be half of number. So then after setting I to 2, we would then run a for loop that would go all the way to limit. So then as long as I is less than limit, it would then divide num by I, which is the number that would keep iterating from 2 to limit. And if the remainder is 0, then its prime will have the value of 0, which means that it is not a prime number. And otherwise, it would be assigned a value of 1. So then after that part, we would have here, you have to print out whether it is prime or not by checking the remainder. So just to look over the trace table. So just like the previous program, the variables having been declared are initialized with 0, with no value at all. So then inputting a number, we come here, but before we get to that, we'll then have for our first output, enter a number. So again, for the sake of demonstration, we'll use, let's say, 13. So when you divide it as an integer, when you divide an odd number as an integer by 2 or pretty much any value that has a remainder, it would default to the integer value that is attached to the decimal. So the half of 13, as you know, is 6.5. But in it, when you're declaring it as an integer and it's being read into an integer, then it would only read the 6. You would have to use a float then to store in the decimal places, but for this program, we can just use an integer. So 6 would then be our limit. When we come at this point and divide 13 by 2. So then after that point, you'll come into our for loop here. So I is immediately set with the value of 2. So then we will start from 2, and then the number will increase as we divide. So here, there's a built-in incrementer into a for loop. So here, as I have written down here, I would be equals to 2. And then it would then test 13, divide it by 2, check the remainder. And if there is no remainder, meaning it is completely visible, then it will then return this condition here, meaning its prime would then be set to 0. Otherwise, it'll be set to 1. And here we can see that its prime should be set the value of 1, since 13 isn't divisible by 2, right? So then that has been executed. So then this block of code will be run yet again, but this time the value would be 3. So the value would increase with each iteration. So now at 3, 13 would get divided by 3. And if there is no remainder, meaning that if 13 mod 3 is equals to 0, then it would, as I said before with 2, assign 0 to its prime, and else 1. And as you can see here, its prime should remain 1, since it is not since 13 can't be divided by 3. So we keep going for 4. So if 13 is divisible by 4, then its prime is equal to 0, and otherwise its prime is equal to 1 as before. And it should remain as 1, and then for 5 should be the same. So when we get to 5, that will be the last number that would be iterated, and then upon iterating again and hitting 6, it would break out this loop and then come down here. So after being all set to 1, then its prime would be tested at this point, and then if it is 0, it would return num is not a prime number, and otherwise would print num is a prime number. So then we predict that it would print out that 13 is a prime number. All right, so I will stop here and restart promptly because we're going to run out of time now. So when we start back, I will show you this code in C and then run it to see if our trace table here is correct. All right, so I will end this and restart. Okay, so as I said just now, we will restart by demonstrating this program. So I'll just have this program here and just put our trace table on the side just to compare. So in fact, I'll just put up the algorithm just to compare. So just let me zoom in here. Okay, good. So let me just show you the code. So here we have limit I and is prime being declared as integers. And as I said, once they're declared, they'll be set to 0 automatically. So then we have here, enter a number, and then it'll read in that number. And that'll be our first output after having all of our variables declared. So then we would move on to limit then being set as num divided by 2. So then here, we'll come into the for loop and I being given the value of 2, which we can conveniently do in the for loop itself with C. We would then have here our conditions. So as long as I is less than the limit that's been set up here, I will increment, which is the same as I equals I plus 1. But for shorthand, we just use I plus plus. So then inside this for loop, as it continues to increment as long as this condition is true, we then have if mod divide I is equals to 0, meaning that when num is divided by I and there's no remainder, then as said up here, it should store 0 into is prime. And then here, this is just a break that I have here for in case it were to continue to run and then meet a number that can divide it after having already been set to 1. But I'm not sure if this is necessary or not, but I just have it in here just in case. So this would be our default condition, and otherwise it would store I into is prime just as I explained here with this algorithm. So it'll keep going until we reach the limit and then come down here and test see whether there was a remainder or not with our flag variable. And then if there was no remainder, it will print out that it's not a prime number. And likewise, if the opposite, if there is a prime number. All right, sorry, this asked me to save the recording just now. All right, so now having gone through that, we can run this program and then input our test data that we have here and see if it actually does what we want it to do. So let me try this then. And then put the code up here. All right, can't put the code here. Okay then. Excuse me for a second. All right, so I got it to work. So we can have our code here and our program running up here. So here, just as I said, after this point, the variables have been declared, everything has 0. So our first output then would be enter a number as expected. So we come down here, num is then inputted and limit is calculated. So let's use our test data here and put in 13. So once I enter 13, limit will be immediately calculated and this for loop would run. So it'll keep running from 2 to 6 and divide the numbers and see if there's a remainder or not, just as I said just now. So it will run all this right now and then test if there is a remainder. So as if the result that we expect is that it will show that 13 is a prime number, right? So let me just enter here and here we have it. 13 is a prime number. We have our desired output. All right, so understand? All right, so now we can do, now you can do one of these questions here. All right, so write an algorithm that, well, this is actually one that we have done before that I was planning to do as a demonstration, but you can do it too. So the question here is write an algorithm that calculates a running sum of numbers that the user will enter and would be added to the sum. But when a negative number is encountered, it would stop adding the numbers and then print the final result. So let me just put it in chat for when I do have to change the screen. So tell me, what is the problem that we're trying to solve here? right, so we want to get the sum of the numbers and until we encounter a negative. So let me just put that in here. Right. So with this problem here, what do you think our inputs would be? Right, the numbers to be added to the sum. Right, so the output then would be the final result, right? The final total sum result. Okay, so what processing we needed to get to that point? We can use a while loop to continuously add, right? That can work. So using a while to continuously add numbers. With the condition that that num is greater than 0. Okay, that can work. All right, so with this, we can then go and do our IPO table. So come down here and well, you set your input to, or we can just use num, right? Since you already gave me num in the chat, right? Okay, so we can just put in num. All right, so what would be the processing steps in detail? Check to see if the number is greater than 0. If yes, continue. If oh, and for loop display the total. But we should also put up here under the if yes part, continue the loop and add add the number to the total. So these steps here look good. So then under final output, we'll just put the final total sum. Right, this looks good. So using this, let's do our algorithm. Right, so start. Clear num as integer. So while num is greater than 0, all right, so yeah, declare sum as well. All right, so we have sum declared. So come down in here, print enter a number, and then read num. Let me zoom a bit. So what next? Come off the loop and then do the rest of the program, or you want to add more onto this? All right, so then sum is equals to sum plus num. Right, then we exit the loop. Then print the final sum total is num. And then we should have initialized sum is equals to 0 as well. Right, yeah, that makes sense. So we'll initialize sum equals to 0 and then stop. All right, so we have an algorithm developed. Not sure if it's right or not, because we're going to have to test it to make sure if it is right. So I have this trace table right here, and I'll just put this algorithm in the chat so that we can look at it together. So now let's test this. So our variables are num and sum. So I'll just get rid of these extra columns right here. So when everything starts, everything would be initialized to 0, right? As we have here, sum is also initialized to 0 in the actual declaration itself. So let's just put here variables are cleared. All right, then, so according to our algorithm, what should be our first output? So the program should run with 0, well, because it isn't larger than 0. I think I might have a problem here because if num is equals to 0, then how will the while loop run? All right, so just come up here and put this as greater than or equals to 0. Okay, so now this while loop will run. So then what should print now that the while loop can run? I think I might have to print enter a number first, since that would be our first output. Okay, so let's just paste this in here. Make this a bit larger. All right, so what number would you like to demonstrate with first? All right, 10. So a number is entered while loop starts. So as we go through, it then sum then becomes 10, right? So next, want to put a different number. Eight. So then sum would be 18, right? And then I think we can do one more number. All right, 26. So then that would be 44. So then we can put in a negative number here. So -5, sum would remain at 44. And then we can just put here the while loop terminates with a negative number. All right, so after all of that, we should then have the sum be printed out. So we'll keep this -5 here since that's still the value of num at the moment. Put this here as 44 again. So now what comes here is that the sum would be printed out. So what will be the output then? The final total sum is 44. All right, so now that we have some test data and what we expect it to result in, let's try to implement it to see whether it actually does what we hope it does. So let me go and get the C editor up. All right, so I have the C compiler back up again. So I'll just, quick question, have you done C yet? All right, so you can tell me what to write then. You can just tell me what to type in chat. Okay, no problem. All right, I see you put it in chat now, so I'll just paste it in. All right, so pasting in now. I just have to format this since the compiler does not like how some quotation marks are, so fix that. Mistake at num, it should be right here. Okay. This. All right. That was here too. All right. So this is your, let me just give myself a bit more space here. Oh, okay. So put a bracket here and here too. Type, oh, you typed it in Word. No problem. I guess you can see why programmers don't use Word. Because I've honestly tried before and it was a headache. So, so this is your final program here. Fair enough. So, all right, so using the test data that we have over here, let's just see what happened. Okay, we'll just see if it comes out to what we expect it to come out to. Right, so let's compile and run. I'm just gonna ask to save first. So total.cpp. All right. You see the screen come up? Okay, great. So let's enter in 10 here. All right, so 10 should have been read into num and then added to the sum. So let's run in it. The same should have happened. Let's now put in 26. All right, that should have been read as well. And now let's read in -5. And hopefully the loop should terminate with this negative value. It looks like it took off the 5 that was inputted here to terminate it. Oh, all right. So let me just close this out. So let's troubleshoot this program. How would you personally solve this problem? Oh, sorry. I just said, all right, we might have to restart soon because we only have a minute and a half left. So let's just restart this again, and then we can troubleshoot this program. So after that brief intermission, we can now come back to this program and try to troubleshoot it. So the problem here is that when we are inputting our numbers and when we get to the negative number, which should in theory end the program, it adds that number into it. So if I may, let me try putting this up here before before this part just to see what to see if it actually will still do the same problem that we had just now. Just a slight change. So let me just get this meeting chat over here. All right, so 10, 8, 26, trying back -5. Huh. So we're closer to our answer, but it is finding an extra 1. So what can we do here that would solve this problem? Put it outside of the loop. Okay, so put it after. So like here or above it after. Okay, so this can be left here then. true. It wouldn't add the numbers. Uh, so looking at what we inputted and what it came out to be, all we were doing was just adding nums. So it got a one from somewhere. I am not entirely too sure where the one came from. So would it be would it be a good idea if we put and if we printed out num just before the while loop just to see whether it actually is, if there actually is a value put in there. Oh, sorry. I was wondering that since have the only thing that sum is being set to is sum plus num, that means that somewhere along the line, we're inputting one more value than one more number is coming from somewhere that we aren't sure about. The people who are probably watching this video can probably see if I made a mistake or not when I input the numbers, but perhaps we can just try again because this really is strange. I'll just try to input the same numbers again and try just to make sure I didn't actually make a mistake. So 10, 8, and 26, and then minus 5. Huh. So that is not my personal mistake, but something here is going wrong. So not sure if you've been introduced to it or have already come across it while you were doing your coding, but we could probably do what is called a flag variable or a watch, just a variable that its only purpose is to just show us what our processing looks like in real time. So let's just copy this and perhaps just change it just so that it'll actually just keep showing what the sum is after each repetition, just to make sure that what we're inputting as our sum is actually our sum. So let me just put end character here just to so it wouldn't be all on one line. Right. So let's try this to see if our sum is adding up as we intended to when we put in each number. So, oh, okay. So I guess you can see here, sum has a value of 1, meaning that num likely has a value of 1 as well, given that's the only thing giving sum its value. So Let's just isolate the problem again and just show num. So let's run this again. And if what I was thinking is correct, then it would say num is equals to 1. Okay, so num does have the value of 1. So in light of this, what do you think we should do? Right, so initialize num equals to 0 at the beginning of the loop. So put here num equals 0. Let's just try this. Also put in something here so that we can see what sum is as well. So that's how you do multiple variables. If we're outputting multiple variables, you just put it like this. Right, so let's try this and see if it works. So number and sum is both 0. So now let's put in 10. Okay, so sum still looks like it is. Sum is still being stored as 0. I think it's because it's at the beginning of the loop itself. But let's continue on. Oh, let's just try it out, and our sum is 0. So while initializing num as 0 was a good idea, I think the problem here with putting it here is that once you go and put in num and it reiterates, num gets reset to 0 before it even reaches the sum. So where would be a better place to put this? So before the loop. Okay, so let me just cut this and paste it up here. All right, so we have num equals 0 before the while loop. And let's try this out. So both are set to 0 as expected. So enter a number, we put in 10. All right, good. So 10 has been stored in num and has been added to sum. So let's continue on with 8. Right, so as you can see here, this and our trace table is matching so far. So now let's add 26. Very good, seems to be working. And then let's add in -5. And good. Looks like your program is working now. All right, so we have successfully done a problem and then implemented it in C. Great. I had more questions to do, but not sure if we'll still have enough time left to do it. So know that, well, you can know by know that you have known that you know C now. Maybe I can ask you to do those questions. I'll actually send them in the chat this time. And then you can do the same stuff that we worked on just now with the finding out the problem, inputs, outputs, processing, the IPO table, do an algorithm or a flowchart, either can work, and then do a trace table for that would use to test the algorithm and then implement it. So that'll be okay with you. All right, good. So know that there isn't anything else I'll have to say. I'll just send the questions that I have here, prepare in a document and send it off right after. So that is the end of class. Thank you for joining, and I'll see you next week. Good night.